It's taking its time tonight. It's thinking. I've got like a little recording circle thinking. Here we go. Okay. And let me share my screen. Okay, question 1 for tonight. This was taken from the DBE Feb paper in 2015. A quadratic sequence is defined with the following properties. So they've given you some things, they've told you some things, and the whole question in total is out of 9 marks, but the first part is write down the value of T5 minus T4, and then T70 minus T69, and then your final question. I am going to give you tiny pieces of help here, but not a lot. Oh, I have to open this again. It's done that weird thing. So just remember your stepping stones with quadratics. And then remember that your first differences make up a linear pattern, and your linear pattern is that. That is my help. I'm going to give you some time to think it through though. Do your best. It's lots of marks, so you have lots of time. Bye. What did you get for your paper 3? Sure, that's a high marker, boo. Yeah, I probably would have done the same in fairness. When you start having your answers, pop them in the chat for me. So just start with like 5.1a and then look for 5.1b. My hint to you is that these are looking at your first differences. So think about it in terms of linear, and then you can tackle 5.2. That's my advice. You don't have to take it, but that's my advice. Yep, I like that. T5 minus T4 is going to be 25. So what we see here each time is that we are adding 6. Because remember, it's a linear pattern because it's my first differences. So that means that T5 minus T4 is going to be 25 because I'm going to add 6 again. 1 mark for that. Hmm. Oyanda, are you missing some numbers? Or are you just, is your answer just 6? Ooh, you're getting some different answers. I like it. So I can tell you that one of the answers on the screen is correct. You are losing the plot, Oyanda. Yeah. I think you're thinking about it like the second difference. So the second difference would be 6. But the first difference, that's these numbers here. That's such a sad way of looking at it. Shame. I'm going to give you guys 2 more minutes on 5.1b, and then I'll do it on the board. If you've done with it, you're welcome to carry on with 5.2. And if you need more time for B, please let me know in the chat so that I don't rush you. Okay, so let's have a look at 5.1b. I would start it by actually just drawing something out. So this is my quadratic over here. Okay, my quadratic is term 1, term 2, term 3, term 4, term 5. We don't know what those are right now, but we know that the difference between those two is 7. The difference between those two is 13. The difference between those two is 19. And the difference between those two is 25. Okay. So that means that we know that A is 7 and D is 6. So if we put that into our formula, we've got Tn is equal to 7 plus n minus 1 times 6. So Tn is equal to 7 plus 6n minus 6, which means Tn is equal to 6n plus 1. Okay, that's the first step. Now we've got to figure out T70 minus T69. Okay, so term 2 minus term 1 of our quadratic gave us term 1 of our linear, term 2 of our linear. So it's always going to be that number. So if we're having a look here, T70 minus T69 of our quadratic is going to equal T69 of our linear. So we are now wanting to make n equal to 69. So we're going to say T of 69 is equal to 6 times 69 plus 1, and that gives us 415. 3 marks for that one. You would get a mark. Yes, sure. From which part are you under? Are you happy with the linear equation that's on the board right now? Okay. So then what we're looking at here is that 7 is T1 of our linear. This is T2 of our linear. This is T3 of our linear. So T2 minus T1 of our quadratic is equal to T1 of our linear. That means that T70 minus T69 is going to equal T69 of our linear, because it's always going to be that smaller number. That means that n is 69 of our linear. So all we got to do is pop that in. So T of 69 is equal to 6 times 69 plus 1, and that gives us 450. Okay. All right, I'm going to give you some time to finish up 5.2. The key to 5.2 is this and that. So wherever you see yellow on the board, that's the key. Does it show as orange on your page? It's yellow on my side, but I can see how it's orange on yours. Let's go with orange. Wherever you see orange, that's going to help you with 5.2. It's orange? Okay, we're going to go with orange. I mean, at least it's a light orange. I would say it's yellow adjacent. So is 2 more minutes enough for 5.2? If not, let me know. Let's see. Oh, yeah. Oh, yeah, it's not what I've gotten. Doesn't mean it's wrong. Okay, Leander, let me think of a different way that I can write this. No, I don't want to use orange so that I don't confuse people. Okay. Oyanda, my quadratic sequence is pink, T1, T2, T3. My first differences of those, so T2 minus T1 is going to be T1 of my linear. I'm actually going to write these two in pink so that you can see. So of my quadratic, T2 minus T1 is going to give me T1 of my linear. T3 minus T2 is going to give me T2 of my linear. So if I had to write that down, my quad, if I had T2 minus T1, it's going to equal term 1 of my linear. So by using that logic, term 3 minus term 2 is going to give me term 2. Term 4 minus term 3 is going to give me term 3. So therefore, term 70 minus term 69 is going to give me term 69, because it's always going to be this number here. Oyanda, let me know if that helped. Cool. Yeah, okay. All right, let's have a look at this. I'm going to write this out. So I'm going to draw some things here. I'm going to keep this as we are. T1, T2, T3, T4, T5. Okay. And my first differences were 7, 13, 19, 25. I'm just going to move that down. I will scroll out so you can see everything all together. And then my next ones, my second differences are going to be 6, 6, 6. Okay. So now we're going to think about our ladder. A plus B plus C, 3A plus B, and 2A. This dude needs to equal 2A. This dude needs to equal 3A plus B. So let's start there. So 2A is equal to 6. Therefore, A is equal to 3. Done. Cool. Happy days. Let's look at the next one. 3A plus B needs to equal 7. So that's 3 times 3 plus B, which needs to equal 7. 9 plus B needs to equal 7, which means B is equal to -2. Before I do anything else, does anyone have any questions about that so far? Abu, because it was given to you in a different way. It was purposefully there to try and trick you. That's why I said they're tricky questions tonight. Now we don't know C, okay, and we don't have this number. So we can't find C the way we normally do. So what we're going to do right now is we're going to write things out. We have Tn is equal to An squared plus Bn plus C, right? So Tn is equal to 3n squared minus 2n plus C. We still don't know C. C is lost to us right now. However, we do know, you see, I would call this color orange. For me, this is orange, and the other one's yellow. But anyway, I digress. We have this important information over here. That's telling us that when n is 89, Tn is 23594. That's what that information is telling us. So that means we know what that is, we know what that is, we know what that is, which means C will be our only unknown variable. Which means we can find it. So I have 23594 is equal to 3 times 89 squared minus 2 times 89 plus C. I got 14154, Leah. But now I'm questioning if I did something wrong with my calculations. Okay. So if we work this out, we see that C is equal to 9. That means that my formula is going to be Tn equals 3n squared minus 2n plus 9. Now, we want to know the value of term 69. So we want to know what term 69 will be. So that's 3 times 69 squared minus 2 times 69 plus 9, which gives us 14154. And that, my dear grade 11s, is 5 marks. I'm going to zoom out so you can take a screenshot of the whole question if you would like. There you go. Yeah, but I'm purposefully giving you hard exam questions now, Abu. I am, Kanyo, don't you worry. All of our questions tonight are spicy. Okay. All right. We will come back to question 7, but I want you to do question 8 while your brains are still fresher. A sequence of isosceles triangles, so remember isosceles triangles mean that two of the sides are the same as each other, is drawn. The first triangle has a base of 2 centimeters and a height of 2 centimeters. The second triangle has a base which is 2 centimeters longer than the first one and a height which is 1 centimeter longer. The pattern of the enlargement will continue with each triangle that follows as shown below. So we've got all of these different triangles. First thing we need to do is, because the question's talking about area, we need to figure out the area of our different triangles. So how do I work out the area of a triangle? What is my formula? And this is why we're going to do measurement revision, so that we are able to answer questions like this, just so you know. Good. Half base times height. Okay, so base times height. So for this one, 2 times 2. So that's going to be 2 centimeters squared. Next one. And the next one. Once you have that, you have your pattern, and then you can answer the questions that follow. I have given you help. Oh yeah, I didn't get that, if that helps. But then I also didn't get what Abu got. Ah, okay. Abu, that's more similar to what I got. You are not close. You're there. You're on the money. Okay. I'm not going to do 8.2 just yet, but for 8.1, for triangle 1, we know the area is 2, triangle 2, the area is 4, triangle 3, the area is 12. So that means that my first difference is 4 minus 2 is 2, 12 minus 4 is 8, which means my second difference, 8 minus 2. Hold on. I feel like I've done something weird. I put the wrong numbers here. That's what I've done weird. Here we go. Okay, so 6 minus 2 gives us 4, and 12 minus 6 gives us 6, and then 6 minus 4 gives us 2. So that's what we're needing. Those are the important things. Okay, so we can see it's going to be a quadratic, which means we care about these 3 dudes. We care about our stepping stone. So we care that 2 is A plus B plus C. We care that 4 is 3A plus B, and we care that 2 is 2A, and we work from the bottom up. So 2A equals 2, therefore A equals 1, which means 3 times 1 plus B equals 4. So 3 plus B equals 4, which means B is equal to 1. And A plus B plus C. So A plus B plus C needs to equal 2, which means C is equal to 0. So that means that my formula is Tn equals n squared plus n. And they want to know the area of the 100th triangle. So they're asking when n is 100. So T100 is equal to 100 squared plus 100, which gives me 10100. Abu, I don't hate that answer. Can give you a couple more minutes to finish that up. For 8.2, it's now asking us to basically go backwards. It's saying, cool, you've already figured out the formula, but which triangle will have an area of 240? So it's telling us that the Tn is 240, and we want to know what the n is. And we have our formula already, so our life is okay. So for 8.2, Tn is equal to n squared plus n. And now they've told us that Tn is 240. So this is going to be n squared plus n. It's a trinomial, so I'm going to move everything to one side and make it equal to 0. And then I'm going to factorize. And I'm going to have n plus 16, n minus 15, which means that n is equal to negative 16 or n is equal to 15. And remember, patterns can't have a negative n, which means n is going to be 15. So therefore, triangle 15. Okay, take a screenshot if you would like, and then we're going to jump onto our next question. Okay. Question 7 starts off very kind. I expect everyone to be able to get those first 6 marks, no problem. The last 4 marks get a little bit spicier. So enjoy the nice, happy questions with 7.1 and 7.2. Get those 6 marks in your pocket. Leander, that's not what I got. Okay. I think what you meant, okay, yeah. Yeah, and I think what you meant was this is the first difference between them, -2, and that is correct. Yes, Uya, P is definitely negative 13. I'm just going to put that on the board so long for those of you who are working for 7.1. You know what you did, Tebogo, is you plus 2 instead of minus 2. So write it out like this. P minus negative 11 needs to equal negative 2. So P plus 11 needs to equal negative 2. Therefore, P is equal to negative 13. Interesting, Abu. Very interesting. You might want to look at a sign somewhere. I agree with what you've written. You've written A equals 1, B equals negative 9, C equals 7, but that's not what you've written when you said Tn is equal to. Oh, yeah, that's better. Where did the minus come from? I don't know. Okay, so for 7.2, these are the values we care about. So we're going to say 2a is equal to 2. Therefore, a is equal to 1. 3a plus b is equal to negative 6. So 3 times 1 plus b equals negative 6, which means b is equal to negative 9. And a plus b plus c needs to equal negative 1. So 1 minus 9 plus c equals negative 1. Therefore, C is equal to 7. So my formula is Tn equals n squared minus 9n plus 7. And those are our first 6 marks. Now, I'm going to give you some time to see if you can try and sink your teeth into 7.3. And remember that first differences make up a linear pattern. These explain A. Where, okay, so for 7.1, right, I'm going to write this in a different place. Okay. That's the information we know so far, right? So we have our quadratic sequence at the top, and then we know that we have our first differences. And our first differences always have a constant difference. So if these two differ by 2, because negative 6 plus 2 will give me 4, then I'm going to do the same thing over here. So I'm going to add 2. So negative 4 plus 2 is going to give me negative 2. Now I know what the difference is between them. So if I think about these terms and this, I know that P minus negative 11 needs to give me negative 2, which means P plus 11 needs to give me negative 2, which means P needs to equal negative 13. Yeah, did that help? Okay. Abu, can I just tell you that I don't hate that answer? And this is a very hard question. Okay, I'm going to give you guys 3 more minutes. I'm going to give you till past, and then we're going to talk this one through. Last minute. Okay, we're going to go through this one nice and slow. If at any point you don't understand, please let me know in the chat so that I can explain it. (7.3). First thing I'm going to do is I'm just going to write out our pattern again so that it's in a clean space. We've got -1, -7, -11, -13. First differences, -6, -4, -2. Second differences, 2. Okay, that's the first part of what we're going to do. Next thing we're going to think about is they're saying the first difference between two consecutive terms of the sequence is 96. That means that somewhere in here is 96. One of our first differences is 96. So we got to figure out which linear term that is so that we can then figure out which quadratic terms, what their values would be. Okay, so let's first find the formula for our linear sequence. We know that in our linear sequence, this is our linear sequence over here, A is equal to -6 and D is equal to 2. Okay. So let's put that into our formula. Tn is equal to -6 plus n minus 1 times 2. Tn is equal to -6 plus 2n minus 2, which means Tn is equal to 2n minus 8. So that is the formula for the linear sequence that is created by our first differences. Before I say anything more, does anyone have any questions or not understand what I have just said before we dive into more? Okay, cool. So that's part 1. Now part 2 is we need to find out which term this is. So we know that that is going to be our Tn. So we're going to say Tn is equal to 2n minus 8. So 104 is equal to 2n, which means n is equal to 52. Okay, so that means that this is going to be term 52 of our linear sequence. And I'm just going to remind you what this looks like. It's exactly the same concept that we did earlier. So term 2 minus term 1 of our quadratic is going to give us term 1 linear. Term 3 minus term 2 of our quadratic gives us term 2 linear. That means that term 53 minus term 52 is going to give us term 52 of our linear. Okay, before I carry on, I'm going to check again. We're all good so far. Okay. Now we've already got our formula. We worked out Tn equals n squared minus 9n plus 7. So now all we have to do is we have to substitute in our 53 and our 52, and we're good to go. So we're going to say, therefore, term 52 is equal to 52 squared minus 9 times 52 plus 7, which gives us 2243. And term 53 is equal to 53 squared minus 9 times 53 plus 7, which gives us 2339. And those would be our two terms. So scroll out so you've got the whole question. If you want a screenshot, feel free. And then I think we can sneak in one little question more. We might not get through all of it, but we can get through some. So the thing is, a measurement is technically part of the syllabus all throughout matric, but it's not something that is necessarily taught each year because it's considered assumed knowledge. So you get taught it in grade 9, and then I think a little bit extra in grade 10, and then it's considered to be taught. So it doesn't get like retaught in grade 11 and matric, but they can ask you questions about any of the area or volume or anything because it's already been taught to you. That's why we're going to do measurement together from next week so that it's all fresh in your brains. So I guess my answer is yes and no. Yeah, that's weird. All right, let's end with one last little question. Let's stop here. Let's just do 9.1 and 9.2. Ooh, maths teacher's having extended class time. That sounds exciting. I like those answers, absolutely. So this one over here is going to be 209, and this one is going to be 186. And now for 9.2, we just need these dudes and our little ladder. Abu, I don't hate that answer. Okay, I'm going to start talking through it just because our time is running out. So when we're looking at this question, we care about the 3 that I've circled. So we're going to say 2 is equal to 2a, which means a is equal to 1. Then we've got 3a plus b is equal to negative 31. So 3 plus b equals negative 31, which means that b equals negative 34. And then for the last one, we've got a plus b plus c needs to equal 321. So 1 minus 34 plus c equals 321. Negative 33 plus c equals 321. Therefore, c equals 354. So our formula is going to be Tn equals n squared minus 34n plus 354. Desdemonia, if what you're asking for is up here, I would make that x and y, and I'd work that way. So I would say, okay, x minus 234 needs to give me negative 25. And then you can just move this one over. So you'll see, okay, cool, x is 209. That gives you that value. And then for this one, I would say y minus 209, because you've now worked that out, equals negative 23. Therefore, y is equal to 186. And then you've got that one. Hopefully that helped. Okay, lovely 11s. That is the end of patterns. Patterns are done. Next week we start measurements. But have a beautiful weekend. And I will see you all next week, Tuesday. Bye. Beautiful finish.